So I welcome you all to this session. I am Mr. Department of Mechanical Engineering. So I am going to tell you that is 4th semester Diploma Engineering course. Thermal, that is the subject is your Thermal Engineering 2. And today we will discuss your chapter 1, that is performance of IC. So what we are going to discuss in this video, that is we are discussing what is power, what is mechanical efficiency, what is indicated thermal efficiency, break thermal efficiency, relative efficiency, volumetric efficiency, mean effective pressure, and specific fuel consumption. Also, we will discuss how you define air-fuel ratio and what is the definition of calorific value and what is calorific. So we know that IC engine which convert the chemical energy of the fuel into its mechanical energy, mechanical work is also a form of energy, and some of the performance parameters are set so that we can know that engine will be in good working condition. So these are the basic parameters are which is your power, that is your brake power, indicator power, piston power, and by efficiency we can measure the performance of IC engine, that is your mechanical, brake thermal, indicator, volumetric, and relative efficiency. Then according to the fuel consumption, that is brake specific fuel consumption and indicator specific fuel consumption, we will see the performance parameter of your, or you see the performance of your IC engine. Then first we will discuss how the power will be generated. So this is your energy flow in the engine, flow diagram of engine. So what will happen if you say that in case of your diesel engine or in case of your petrol engine, both the engine, the air fuel mixture will be burned in the engine cylinder or in the combustion chamber. Where the air fuel mixture will be burned, that is known as the combustion chamber. So when the air fuel mixture will be burned, the mass of fuel, and every fuel has its calorific value. So when the petrol or diesel will be burned in presence of air, it must have some calorific value. With this calorific value, when it will be burned, it will produce what? It will be produce heat energy. Okay? And that heat energy is gradually converted into what? Is converted into work, and work into power. So what is power? Power is your rate of work done is known as your power. Work done per second is known as your power. So when the heat energy, when the mass of fuel with its calorific value, when it will be burned inside the cylinder, it will produce some gas or produce some heat, and that heat will be transferred from the piston to the crankshaft. So the heat produced, or rate of work done on the piston. So when the heat will be produced, and when the air fuel mixture will be burned, it will produce some gases, and that gas will be give the force to the piston, and piston will be moved from TDC to PDC. That means on the piston some work will be done on the piston. So rate of work done on the piston, so that is known as your part. Which power? Indicated power. And here you can see that we get this much of power. Mass of fuel into calorific value, suppose you are getting 100% of energy you are getting. But from the 100% of energy at the piston, the rate of work done on the piston, or that work you got in the piston, that is your 80%. What are the 20% will be losses? 20% will be lost in case of a cooling and radiation. So when heat will be produced, know that to cool the engine, it may be air cooled engine or water cooled engine, and using the coolant, so coolant will be take some heat, and because of radiation, some of the heat will be losses, and that after losing all this in cooling and radiation heat, the amount of heat which will be converted to work, that is your indicator rate of work. And when the piston will be moved from TDC to PDC, the power will be transmitted to the crankshaft through the connecting rod. So what this connecting rod, crankshaft, and your piston all are moving elements. So because of moving, some of the power will be lost in the because of friction, and the ultimate power that we get we get in the crankshaft, that is known as your what? That is known as your brake power. So that will be utilized. That will be useful. This brake power is useful, not the indicated power. Indicated power that is got inside the engine cylinder. So from the engine cylinder, the wheel are not attached so that you can utilize the power. Power will be transmitted to the crankshaft get the power that is known as your what? Brake power, and this brake power will be utilized for the further use. This is what the energy. Then first we will discuss what is power. So what is power? You know that IC engine is used to produce mechanical power. How it got the mechanical power? By combustion of fuel. It will be converted to heat, heat will be converted to work, and the rate of work done is the power. So power that will be expressed in case of a linear velocity, that force into displacement of force into linear velocity. Or you can say in case of a rotating device, the torque into angular velocity. So here crankshaft is a rotating device. So what we get? We have to calculate the torque or force and the velocity. So the velocity means you have to calculate the speed. So from where you get the torque? In the crankshaft. Torque will be measured by your dynamometer and the speed of the engine will be measured by your tachometer. From that we get the power. Okay, so first we will discuss indicator power. What is indicator power? As I said, that the power that produced in the cylinder, or you can say rate of work done on the piston by burning of charges, that is known as what? Indicator power. The engine cylinder can जितना भी power मिला उसे हम क्या बोलेंगे? Indicator power. So how you calculate indicator power? The pressure from force will be applied. Force per area, unit area is your pressure. So force will be applied on the piston, and piston has some area. The force per area is a pressure. Some of the pressure will be applied so that piston will be moved from what? TDC to PDC. TDC when the piston will be moved from TDC to PDC. The volume covered by the piston is your swept volume. The force is your what? That pressure into swept volume. Volume displacement. Displacement is your LA. What is LA? Pi by 4 T square L. That is your what? Swept volume into NK. N that is your small. N is a number of working stroke per minute into K is a number of cylinder. Divided by 60 is not give us a what? It will give us power. So we know that power is equal to force into displacement. What is the force here? In terms of pressure, that is PIN, mean effective pressure, and L, that is your pi by 4 D square into area is your area of the piston, that is pi by 4 D square into L, that is your swept volume, into number of working stroke, that must be small n, into K, number of cylinder divided by 60. It should be in kilowatt. How you got in kilowatt? Because if the mean effective pressure in kilopascal, then you got the power in kilowatt. So what is the number of working stroke per minute? Small n. Small n is equal to speed of the engine by 2. That is in case of 4-stroke engine. And your number of working stroke is equal to speed in case of a 2-stroke engine, where K is the number of cylinders. And what is the P suffix IM? That is indicated mean effective pressure must be in kilopascal. So by using this formula, I can calculate what is the indicator power. Then we will go for brake power. So what is brake power? Brake power, that power available at the crankshaft is known as a brake power that will be utilized. So how you get the brake power? The brake power, we have to calculate the torque and the speed. Torque into angular velocity. So what is the torque? Torque is equal to force into distance, that is known as a torque, into its angular velocity. From that we get the brake power. So brake power is basically is equal to 2 pi nt by 60. Force is your brake power, brake load is your F, force, and velocity, that is your velocity of the brake drum, that is 2 pi r. Because it is a circular section, circular section area is a 2 pi r into how much rotation? N divided by 60, that will be give us what? Brake power. That 2 pi n into r into F by 60. What is your force into the distance? Force into distance, that is your torque. Force into radius is your known as the what? Torque. So 2 pi nt by 60 into 1000 in kilowatt equal. That we get what? Brake power. Okay. So how you calculate this R? This R is known as the effective radius of the brake drum. So there is a drum, and over the drum some rope will be there. So that is a rope brake diameter. From the rope brake diameter, we are getting the brake power. Okay. So how you get this effective radius? We are not only in the drum. Some rope will be also rounded or wounded. So effective radius will be what? The diameter of the brake drum plus the diameter of the rope divided by 2, that we got the radius. Okay. So that is your 1 by 2 into diameter of the brake drum plus diameter of the rope, that will be give us the R. That is the torque. Torque is equal to force into radius, that N is your engine speed. So see, here brake diameter is there, where rope brake diameter here is which. So from that here, and according to the mean effective pressure also we can calculate the brake power, that is brake mean effective pressure into swept volume. What is swept volume? swept volume measure pi by 4 d square L, where area is your what? Pi by 4 d square into L, that is swept volume into N into K, number of working stroke per minute into number of cylinder divided by 60. As I said, that area is the area of the cylinder, that is 4 pi by 4 d square, K is the number of cylinder, L is your stroke, and brake mean effective pressure, because we are getting the brake power by using this power. Average pressure applied to get the brake power, that is known as your brake mean effective pressure in kilopascal. So, as I told in the flow diagram, see, as I told in the flow diagram, that indicated power, when you get the indicated power, some of the power will be lost by the friction, and the power that we get, that is known as the ultimate power, that is your brake power. Here you get the gross power, here you are getting the useful power. Okay, so see that. So how I can say that friction power is equal to what? What is brake power? Sorry, what is indicated power? Indicated power is equal to brake power plus friction power. So what is friction power? Indicated power minus brake power. Indicated power minus brake power, that is known as the friction power. So friction power, it is that part of indicated power which is used to overcome the frictional effect within the engine. So it is the difference between indicated power and brake power. So next we will discuss what are the efficiency.